Welcome back, class. I'm Dr. April Ström, and in this video, I wanted to showcase another example of the quotient rule, but just using a function that's maybe a little bit more complicated than I have done previously. So as a reminder, I have the quotient rule up here, and so anytime we have a function that's created by taking two functions and dividing them, and we're interested in finding their derivative, we would need to find the derivative of the numerator times the denominator, subtract the numerator, multiplied by its denominator's derivative, divided by just the denominator squared. So here's our lovely function, p of x is equal to, in the numerator, we have x to the fourth minus pi x. In the denominator, we have 3 to the x minus square root of x. Okay, we are going to treat this as, well, a quotient, and thus use the quotient rule for finding the derivative. So here we go. I'm going to do my setup as per the usual. So I have p prime of x is equal to, I am going to set this derivative up in the quotient rule format and then find the derivative of all the little pieces. So we first have to take the numerator function, this whole thing in the numerator, and find its derivative. So we're going to take x to the fourth minus pi x, and later we're going to find the derivative of that. But per the quotient rule, we are supposed to multiply by the denominator function. So I'm going to multiply here by 3 to the x minus square root of x. And now we'll subtract off the top function, the numerator function, which for us is x to the fourth minus pi x, multiplied by the denominator's derivative. So we have 3 to the x minus square root of x, and then we'll indicate we have the derivative there. So at least in the numerator, we still have two places in my next step that I'll have to find the derivative of, but not yet. So much going on, we just try to do our setup and move forward from there. But we still have this whole numerator, that's probably the longest division bar you've ever seen in your life, but this whole numerator gets divided by whatever you had in your denominator squared. No derivative there. So we have a 3 to the x minus square root of x squared. Okay, now to finish this problem off, we would have p prime of x is equal to, now let's take the derivative of that function here. Well, it turns out there are two little miniature functions within. So we have to go one by one. So the derivative of x to the fourth, maybe you can just think about that in your mind and recognize that, oh, it's a power function. So bring the 4 down in front of the x and then reduce the power by 1. So we have a new function that we'll call 4x cubed minus, now I have pi x. Do not let the pi throw you. Pi is just a constant number. This is as though like we had 5x and we have to think, well, what's the derivative of, say, 5x? Well, once again, it's still a power. We can think, oh, the power, that's 1 here, pull it down in front, reduce the power by 1, which gets us to a power of 0. No need to write x to the 0. Anytime we have that, essentially what then happens is the coefficient is the only thing remaining. So here in this situation, when I have pi x, same thing. When I take the derivative here, I'm only left with just the constant coefficient in front of the x, which is pi. So I'm now done with the derivative of this first part. Now I just copy the second part, nothing to do there. So 3 to the x minus the square root of x. Then we will subtract off. Again, we just copy this whole function. We're not taking the derivative of that. So we'll copy here. We have x to the fourth minus pi x. But now I have to take the derivative of this whole second function, which came from my denominator. And I notice once again, I have two miniature functions within that I have to find the derivative of each of those pieces. So I look at 3 to the x and I have to recall 3 to the x is an exponential function, not a power function. It's an exponential function. So its derivative must look like this. 3 to the x, again, copy the original function, but then we multiply by the natural log of that base, which was 3. So 3 to the x times natural log of 3 is the derivative of 3 to the x. Now we then need to subtract off the derivative of square root of x. So I'm going to rewrite it this way. In calculus, most of the time when we have roots of any kind, we rewrite them as fractional exponents. So I'm just going to erase this square root of x here and make it x to the 1/2 power, because those are the same things. So I have x to the 1/2 power right here. Now, by the way, if that was a cube root, we would write x to the 1/3 and so forth, okay? So by doing this little rewrite of a square root, it allows us to take the derivative a little bit more efficiently, because now we recognize it's just a power. Yes, of course, it's a fractional power, but we can still use the power rule here. So the power rule once again says, take your 1/2. When you find its derivative, of course, put it in front of our x. So we have our 1/2 x. I had a 1/2 power and I have to subtract 1 from that power. So I have to think 1/2 minus 1, -1/2. So that's my new power on that x, and then I will close this off to indicate that all of that stuff in between these parentheses came from finding the derivative of that denominator function. But I'm not done. Of course, I still have to take this whole thing and divide it by my denominator squared. So 3 to the x minus square root of x squared. Now you might be wondering, can we simplify this big ratio function that's here? Yes, we can probably do a little bit of simplification, but the purpose of this video is really to just showcase how to find the derivative using, in this case, the quotient rule. So we are done with all of that. So I'm going to box this and say, this crazy function that we have right here is in fact the derivative function of our function p of x that we started with. So I hope you enjoyed this video, and if so, be sure to like the video and subscribe to our channel.